Section 5.1, Exponents and Scientific Notation. So we're going to learn our properties of exponents. Many of y'all probably seen these before, but we're going to go over them in depth just to make sure we remember what we do with some of our exponents. So the first rule is the product rule, x to the a times x to the b. With the product rule, when we're multiplying, we add our powers. So it'd be x to the a plus b. We keep the base and add the exponents. Or even if you have parentheses, x to the a times x to the b, it's still x to the a plus b. So for example, if we had x squared times x to the fifth, our answer is going to be x to the seventh. We just add our exponents. But let's make sure we understand why. X squared written out would be x times x. And x to the fifth written out would be x times x times x times x times x, right? So now when we look at that, we see we have 7 x's, so that would be x to the seventh. So when we're multiplying, we add our powers. Make sure you keep the base. So steps, first step, keep the base. And then the second step, add powers. So for one more example before we move on, if we had 2 to the 5th times 2 to the 10th. Some students want to say 4 to the 15th, but we keep the base. So the base stays as a 2 and we add the exponent. So we get 2 to the 15th. So be careful when we have numbers instead of variables. The next rule is going to be the power rule. X to the a parentheses with a b on the outside. That is when you multiply the powers, a times b. If we have parentheses with a power on the outside, that power gets distributed to every power. Well, right now, x and y both have a power 1. So when we multiply, distributing the power b, we get x to the b and y to the b. Same thing with parentheses with division. X has a power 1, y has a power 1. Distributing in that power, we get x to the b over y to the b. So that power just gets distributed in. So for example, if we had x to the third raised to the fifth. Well, it's a power to power rule, so we're going to end up with x to the 15th. One more example. If we had 3 y squared raised to the third power. This is where students sometimes make a mistake, so be very careful. 3 has a power of 1 and y has a power of 2, and it's all raised to the third power, so we're going to distribute that power to every power. So we get 3 to the third and y to the 6th. Don't make the mistake of ever multiplying the power times the base. We don't multiply powers times bases. We multiply powers times powers. So don't multiply the power times the base. 3 cubed would be 3 times 3 times 3, which is 27, and y to the 6 will stay y to the 6. So we end up with 27 y to the 6. For the quotient rule, when we're dividing, we subtract powers. So we're going to have the top power minus the bottom power, again keeping the base. We keep the base and subtract the powers. So for example, if we had, say, y to the 7th over y to the 3rd, we're going to again end up with y to the 7 minus 3, so y to the 4th. But what if we had a power that was bigger on bottom? For example, y squared over y to the 5th. We're going to subtract our powers when we get y to the 2 minus 5. Well, 2 minus 5 is y to the negative third power. So that leads us into our negative power rule. When we have a negative power, just know that negative exponents never make numbers negative. They move things. So x to the negative a is going to move it down. So 1 over x to the positive a. If the negative is on bottom, like in this next part, 1 over x to the negative a, it's going to move up. So it's x to the positive a. The whole base and the power get moved together, just the exponent turns into a positive when it moves. So going back to y to the negative third, it's going to have to go down and become a y to the positive third. And what's going to have to go on top is a 1. So y to the negative 3 is really 1 over y to the third. Let's do another example of a negative exponent. Say, for example, we had x to the negative 5. Well, x to the negative 5 would be 1 over x to the positive 5. So all it does, it moves it up or down accordingly. Don't ever make a negative exponent making a number negative. That does not happen. The 0 to power rule states that anything to the 0 power is, and the magic number is 1. Now why would x to the 0 power be 1? Let's talk about it. Well, if we had 5 and we divided by 5, you know 5 divided by 5 is 1. So if we said we had x to the 6 divided by x to the 6, we know x to the 6 divided by x to the 6 is 1. But we also had the rule that when we're dividing, we subtract exponents, and 6 minus 6 is 0. So if this is x to the 0 power, then x to the 0 power still would have to equal 1. So anything to the 0 power is 1. And the last rule, just as a reminder, don't forget x to the first power is just x. We don't have to put the 1, it's understood to be there. But if you have a variable or a number and it's not showing a power, that power is automatically a 1. So in a regular face-to-face class, I normally would have all my students fill these out, and then we would check them after I gave them about 10 minutes to try them. So I would say pause this video, try these problems, just know there's going to be some tricky things happening, then restart this video. But we'll go ahead and just do them out. So 6 to the 0 power. Well, we know that anything to the 0 power is 1. So 6 to the 0 power is just 1. On number 2, negative 3 times y to the 0 power. Just remember that if there's not a power shown, it has a power of 1. So negative 3 has a power of 1. The only thing being raised to the 0 power is the y. Negative 3 is a base, so it does not move. And y to the 0 power is just 1. So negative 3 times 1 is negative 3. Number 3, negative 3 squared. Be careful. Negative 3 squared is different than parentheses negative 3 squared. You get a different answer. Negative 3 squared actually says keep the negative on the outside and just square the 3. So we end up with a negative 9. But if you had parentheses, then a negative 3 times a negative 3 is positive 9. Parentheses makes a huge difference. So with negative 3 quantities squared, you get a positive 9, but with a negative 3 on the outside, you end up with a negative 9. Parentheses is crucial there. Number 4, 4 to the negative 2. Negative exponents never make numbers negative. They move things. So 4 to the positive 2 needs to go down. Since there's nothing left on top, we'll put a 1. And 4 squared is 16, so we end up with 1 over 16. On number 5, 6 over b to the negative 5. 6 is fine, but b to the negative 5 has a negative exponent, so it needs to go up. Don't move the 6, it's fine where it's at, but b to the 5th should go up. So what's left on bottom is a 1. We don't need a 1 because it's understood to be there, so our answer is 6b to the 5th. So on number 6, be careful not to get flip happy. The only thing that has a negative exponent is c. 9 has a power of 1, so the 9's not going to move. Just c to the negative 3 is going to move up. So the 1's on top, c cubed goes up and becomes positive, but 9 stays in the denominator. We don't need the 1 because it's understood to be there, so we get c cubed over 9. Number 7, parentheses x cubed y squared times parentheses xy to the 4th. There's no power on the outside, so we don't have to distribute a power to any power. We're actually just multiplying x cubed y squared times xy to the 4th. So when we're multiplying, what do we do to powers? We add. Again, this x has a power of 1, so you can put that there if it helps you remember it. So x cubed times x is x to the 4th when we add the powers, and y to the 6th, again 2 plus 4, we just add the powers. On number 8, we want to make sure that we keep the base and add the exponents. So 5 plus 4 is 9. We'll go ahead and leave it as 2 to the 9th, but you can work it out if you'd like. On number 9, those parentheses really don't do anything for us because there's no power on the outside. It just shows that there's multiplication. So we have 2m to the 3rd n squared times negative 3 mn to the 9th. Negative 3 is not a negative exponent, so don't move it. Let's just start multiplying. 2 times negative 3 is negative 6, and when we're multiplying we add our powers, so 3 plus 1 is going to be m to the 4th, and then 2 plus 9 is 11, so we get n to the 11th. So negative 6 m to the 4th, n to the 11th. On number 10, we have u cubed over u to the 8th. When we are dividing, we subtract exponents, so we end up with 3 minus 8. So u to the negative 5. Again, we don't want to leave negative exponents, so we need to move them. So u to the 5th is going to come down, and what should be on top is a 1. So 1 over u to the 5th. These next 4 problems put many of these power rules together. So let's look at number 11. Negative 12 j to the 5th k to the 9th all over 3j to the 3rd k to the 12th. The first thing I would start off is to look to see if I have any negative exponents. I don't have any negative exponents, so I won't have to worry about moving anything. The next thing I want to do is go ahead and start reducing if there's no parentheses. So negative 12 over 3. The negative 12 does not move. It's not a negative exponent. We just divide negative 12 by 3. Negative 12 divided by 3 is just 4. Now when we're dividing, we subtract our exponents. So 5 minus 3 is 2. And when we're subtracting with the k's, we get 9 minus 12, which is negative 3. Really what's on bottom is a 1, but it's understood to be there, so we're okay at this point not putting a 1 down there. But if you want to, you can. At this point, if we have any negative exponents, we need to get rid of them. So this k to the negative 3 needs to go down, but nothing else. Negative 4, j squared stays on top, and k to the 3rd will move to the bottom. Number 12. 3x to the 7th, y to the negative 3rd, z to the negative 4th, all over 9x to the 4th, y to the negative 5th, z. There's no parentheses that we have to deal with, but we do have some negative exponents. To me, it's easier to rewrite the expression without negative exponents and then use our other properties. So let's look at the numerator. The 3 is fine, x to the 7th is fine, but y to the negative 3rd should go down and become a positive y to the positive 3rd. And z to the negative 4th should go down, so we get z to the positive 4. Now looking in the denominator, the 9's fine, the x to the 4th is fine, but y to the 5th should go up because it had a negative exponent. But the z is fine, so the z is going to stay down in the denominator. Now that I've gotten rid of my negative exponents, it's easier for me to finish this problem. So when I have 3 over 9, that reduces to 1 over 3. When I'm dividing, I subtract exponents, so 7 minus 4 is 3, so x to the 3rd. When I'm dividing, I subtract exponents on the y's, and 5 minus 3 is 2. Now in the denominator, I have z times z to the 4th. Remember, z has a power 1, so I'm actually multiplying, which means I add my powers. So I get z to the 5th. You don't need the 1 in front of the x to the 3rd because it's understood to be there, so my answer is x to the 3rd y squared all over 3z to the 5th. So now we get into where there's a power on the outside. So on number 13, we have parentheses negative 3 w squared v to the negative 3rd all raised to the negative 4th power. Remember, if there's not a power shown, it has a power 1. So negative 3 does have a power 1. We will take that power on the outside and we'll distribute it to every power on the inside. Keep the negative 3 in parentheses because that negative was also being raised to the negative 4th power. When I distribute negative 4 times 2, I get w to the negative 8, and negative 3 times negative 4 is positive 12. At this point, I would get rid of negative exponents and make them positive. So negative 3 to the positive 4 will be down, w to the 8th will also be in the denominator, but v to the 12th should stay on top. The last thing to do is probably take negative 3 to the 4th power, so it would be negative 3 times negative 3 times negative 3 times negative 3, which turns out to be an 81, w to the 8th in the denominator, and v to the 12th in the numerator. So number 14 is going to be a lot of fun. We have a power on the outside, lots of negatives. Let's figure out how to do this. So parentheses, 6x to the negative 2, y to the negative 3, z squared, close the parentheses, raised to the negative 2 power. All over parentheses 3x to the 6, y to the negative 2, close the parentheses, all raised to the negative 3 power. So 6 has a power of 1, and 3 has a power of 1. We'll distribute the power on the outside to every power, right? Power times power. So on top, we're going to keep 6 in parentheses. It's going to be raised to the negative 2 power. Negative 2 times negative 2 is a positive 4. Negative 3 times negative 2 is positive 6. And 2 times negative 2 is negative 4. In the denominator, all over, we're going to have 3 to the negative 3. X to the, again, we're distributing the power to every power. So that's 6 times negative 3 is negative 18. And negative 2 times negative 3 is positive 6, so y to the 6. At this point, what I suggest doing is anything that has a negative exponent on top should go down. Anything with a negative exponent on bottom should go up. So 6 squared needs to go down, and it becomes a positive exponent. X to the 4th is going to stay on top. Y to the 6th stays on top. But z to the 4th goes to the bottom. Now in the denominator, 3 to the negative 3rd needs to go up. So 3 to the positive 3rd. X to the 18th needs to go up, but y to the 6th should stay. Order doesn't matter here because it's all multiplication, so you could write it in any order you would like. So at this point, let's start trying to simplify. Well, 3 cubed is 27. It's 3 times 3 times 3. 6 squared is 36 because it's 6 times 6. Now let's look at our variables. We have an x to the 4th on top and an x to the 18th on top. So when we're multiplying, we add our powers. And 18 plus 4 is 22. When we're dividing, we subtract powers, and 6 minus 6 is 0. And anything to the 0 power is 1, so we do not have any y's. The only thing left on bottom still is z to the 4th, since there was no other z's to combine with. So my answer would be, looking at our 27 over 36, we can reduce that by 9. So 27 divided by 9 is 3, and 36 divided by 9 is 4. So we end up with 3x to the 22nd all over 4 z to the 4th. Scientific notation. For a number to be in scientific notation, it should be in the form of a times 10 to some power. Now what is a? A is a number, it's a decimal number, but a has to be in between 1 and 10. It can be equal to 1, but not 10, and everything in between. And n is an integer, so it could be positive or negative, but it definitely needs to be an integer. So this first problem says write the number in scientific notation. First things first, we got to figure out where is our decimal. It's at the end of our number. And we look to the left, we see lots of numbers to the left. We only need one number to the left of the decimal, in between 1 and 10, again including 1, not including 10. So let's start moving the decimal. 1, 2, 3, 4, 5, 6, 7, 8. So we need to move the decimal 8 places to the left. So 5.8, drop off all the other zeros, times 10, and since we moved it 8 times, we'll say n is 8. Now why is it positive and not negative? A lot of students try to memorize if you move to the left it's positive, right's negative, but you got to kind of be careful with that. So I tell students if the number is bigger than 1, so looking at question 1, that number definitely is bigger than 1, our exponent will stay positive. Looking at number 2, is that number bigger than 1? No, it's in between 0 and 1. So if your number is in between 0 and 1, it's going to be a negative exponent. And you'll see we have to move the decimal to the right. So how many times? We have 1, 2, 3, 4, 5, 6, 7, 8. If I move the decimal 8 numbers to the right, there'll be a 4 in front of the decimal, which is what I like, times 10, and it's going to be a negative 8 because that number is in between 0 and 1, so it's going to be a negative exponent. Going the opposite way, let's write the number in standard form. So we have 5.23 times 10 to the negative 8. Writing it in standard form, we have to make sure we move the decimal the right way. With a negative 8, we need to move the decimal to the left, so we make our number in between 0 and 1. Again, make sure negative exponents don't make numbers negative. So we start moving our decimal. 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have 7 zeros, and then a 5, 2, 3. We have taken scientific form back into standard form. And lastly, number 2, we have 6.3 6,378 times 10 to the 6. The power is positive, so we want the number to be bigger than 1, so we're going to move the decimal to the right. 1, 2, 3, 4, 5, 6, which means we're going to have 3 zeros. So 6378000. Putting in our commas, we see that we're at 6,378,000. Again, changing scientific back into standard.